In this round of working with the JavaScript canvas, we're going to start doing some basic animation. Now there's a couple of different ways that we can do it. We can use set interval, set timeout, but the preferred way is going to be RequestAnimationFrame. So we can go and look on MDM's website. We can see how there's some basic things that we can do, set interval and set timeout. Those were the ways that it was done until more recently when RequestAnimationFrame entered into play. And the good part about RequestAnimationFrame is that it throttles back when the tab that it's in is no longer the tab that is in focus. So if someone has multiple tabs up, the animation will effectively pause when it's not on screen, which is good because if someone likes to go on the internet with multiple tabs open in their browser, if those tabs are continually animating, that's eating up CPU or GPU processing power, and that over time can cause the computer to kick on its fan, to start working harder, and it's just not as good. So RequestAnimationFrame really is the preferred way of working with things now, and that's really what we're going to be looking at as we add to our canvas. So what I want to do is add in another image. So the image that I'm going to add in is this simple little face image. We can see it's 64 by 103 pixels in size. So we need to know that for when we add that to our project. So I will call this face image and make it a new image. And it was 64, 103. All right. Now, face image source is going to be assets face.png and image add event listener load. And this is where we're going to have an interesting thing occur. We don't want to just call draw again. I mean, we could, but it's already been called by the other one. But the whole point of using the event listener for load is we want to know when the asset or assets, plural, are loaded. So what I'm going to do, instead of calling draw right away, what I'm going to instead do is call assets loader or loaded as a new function that we're going to create. And I will change it here to assets loaded as well. Now you may be thinking, okay, well, what is that function going to be? Well, we have to do one other thing. We have to make a variable. And that will be our asset load count, and it will start out at 0. Now, function assets loaded. And what we can do within this is set our asset load count. We'll just increase it by 1. So we can use the plus, which would be the same as saying plus equals 1, but I like the cleanness of plus. Then we'll use a simple if statement and say if asset load count is equal to, in this case we know 2. Now if we had a bunch of assets that we were loading, we would store that value. Actually, let's do that. That would be a better practice. So the total number of assets to load isn't going to change, so we could use the cons for it. Well, now we could not only just use images, we could also have audio and things like that. So we'll just do total assets. In this case, I know I'm loading 2. So now I'll say total assets. So if my asset load count is equal to my total number of assets, now and only now do I want to call draw. So what that means is this image is going to load. and it will fire this function where it increases asset load count. Then this image is going to load. Now, technically, we can't control which one loads first, and we want to know that they're loaded before we try and use them, because that's one of the #1 problems we run into with JavaScript that causes errors, is that we try and use something before it's loaded into memory. So it's always important. Now, Jquery has its ready function. That works well. There are some versions of that that aren't quite as clean as the Jquery one with vanilla JavaScript in this case, because the rest of the things will load quick enough we don't have to worry about it. We just need to make sure our images load. And when you're testing locally, you're not really going to see a difference because they'll load so fast unless you change the playback settings to in your developer console to mimic a really slow internet connection, where then you could see it takes a little while for assets to load, and that would cause an error unless you are verifying your assets have loaded correctly. Now, let's just draw that. So we'll tell the context to draw that face image. And let's see, we can just put the face image. Maybe we'll start it out at 0, and let's just try 200 and see how that looks. Okay, no error messages and nothing. So when I look at the code here, what we can do is try and figure out where it's breaking down because it's not displaying it. Now, if I go and pull up my elements, I'll see, okay, so the canvas is there, so we are creating the canvas, so that part of our script is working. So that's good, but why is it not loading? Now, if you look at the code, you may have already found the answer, but I'm just going to go through some simple ways when your code breaks to try and figure it out. So I'm going to just let's log that out and see what happens in the console. So nothing there. So our asset load count is never equaling our total number of assets. So now let's put this here, make sure that this function is running. Go here, okay. So it ran. It only ran one time. Now if I look closer and try and figure out why it only ran one time, I'll see we have image, 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 face image, and image again. It doesn't run twice. I registered the same event twice, but it only will then respond once. Now let's try face image. Now if I look here, help ran twice, and there it is. So now it's working. Okay. So I don't know if there's a code completion or a typing error when I was typing it in, but either way, we've now figured it out. The face image is drawing itself on screen. To use RequestAnimationFrame, what it is we put in the statement RequestAnimationFrame, and then we tell it to call a function. The function we tell it to call is typically the animation function, in this case my draw, that is already inside my project. So with that, what I want to do is I want to animate this face across the screen. I want to just change its X value. So to do that, I'll just create a variable, call it face X position, and now we can set that equal to 0. Now let's go face X position, save this, make sure it's loaded. Okay, it's working, showing up, good. And what we can do is go face X position plus equals 1. Now if I save this and look, it increases it, but we never run the loop again because we didn't do our magic statement, RequestAnimationFrame draw. Now, when I do that, you can see that it's simply animating itself across the screen. And that's good until we get to the end and we're gone. So what we need to do is we need to check for the boundary. So I can say if face X position is greater than my canvas dot width, then at that point what we want to do is say face, okay, actually we'll put it on a separate line to make it easier to read. Face X position is going to be set equal to -64. I didn't use 0, I did -64 because, well, you'll see when we save this and go here, it animates. But I don't want it to then, when it jumps, to start it on screen. I want it to totally start off screen and then animate onto the screen, like that. So that really is all it takes to work with RequestAnimationFrame. Now the proper syntax is we tell the window to RequestAnimationFrame. It does work without, but window RequestAnimationFrame is considered the proper full way of doing it and stating our syntax. So this is a good first step. And if we only have a couple objects that we're working with, this is probably going to be fine. But if we have more objects that we're working with on screen, or we want to put multiple copies, or we want an object to be a more complex object, maybe animated sprite versus just a single image, then we need to introduce something else. And that is going to be a class. We want to take all the properties of that object and enclose or encapsulate them into what is called a class. So then it will store all of its information, and then we can make multiple instances or copies of that class object and put them on screen. So we could have 1, 2, 3, 10, 20 versions of the same thing and easily animate them all independently on screen. And that's what we will be looking at next. To work with classes in JavaScript is a pretty nice thing compared to how things were done before. We use almost what would be pseudo classes, so kind of like classes, and found ways to work around it. But now that you can do bona fide real classes, it just makes everything a little bit easier. One key word about working with classes is the class needs to be loaded or read into memory before you try and use it, because otherwise it creates an instance called hoisting where it tries to pull it up then from later on in your document, and you will get an error message. So with that, what we're going to do is just put the class at the beginning of our script. So to define a class, we just simply say class, and by convention, classes, the name of a class will begin with a capital letter. And I'll just call this one head. And now we put the contents of the class inside a pair of curly braces. And as we work with the class, we have our constructor, and then you're going to have methods. So those are the two key defining characteristics of working with a class. And if you get deep into classes, then you can have classes that you have a parent class, then you'll have what would be a child class, or a class that extends that class. It does something different. So you could have like an animal class, and then you could have a lion class, which would have some different behaviors, but it would still inherit everything of the parent class. So there's ways that we can do some pretty complex things with it, but we're going to keep it pretty simple for our purposes. So in my constructor, I just type the word constructor. It really is that easy. And I'm going to define a couple properties that belong to this class. One will be an X value, and with that, we can start it out at a particular or specific value. So in this case, why don't we just start it out at, that magic number of -64 that we played with before. And we will start the y at 200. Now we may end up wanting to change these values down the road because we may want to make instances of our class not always start at the same position. And that means we'll need to pass in values of where we want it to go, or use random numbers, or a number of different options. Now I'm going to tell this class it will have an update method where we will update its x and y position, and it will have a display method where it's now going to write itself to the canvas context. Key thing with this, you'll notice that I didn't put the images into the class. So we load our image assets, so now they're accessible anywhere within our program. And then our class can now take advantage of that. So now if I say context, draw image, and I'll draw the face image, and we will draw it at this.x and this.y. Now we're using this magic keyword this, so we're referencing the x and y properties. So these are like variables, but when we're putting this in front of it, we're typically referencing then something that belongs to the class. So it's inside the curly braces of the class itself. Now, what we can do under update is simply go this.x plus equals, and we can, now we'll make it animate a little bit faster this time. This.y. If we want to animate the y, we certainly can, or we'll just leave it. I'm just going to let it be similar to what we've had before. So I'll just comment that out, knowing I might come back to it at some point. And then I can say if this.x is greater than canvas.width, then what we want to have happen is this.x is equal to -64. Now I'm actually just going to put this down 100 pixels so that we can see it when we put it on screen and work with it. Now, to work with a new object, what we can do is just go let head. Now I used lowercase. I'm making an instance. Yeah, we'll just start out with head. And that will be a new head, just like that. So we use this new keyword. I want a new instance of the head class. Now, what we can simply say is head.update, head.display. Save this and let's see what we got. And there it is. It's going twice as fast as the other one because it's updating 2 per frame. And boom. Yeah, that's cool, but what if I want 2? So I don't want them to be at the same position. So we're going to modify this class just a little bit. And in the constructor, we'll just pass in an x and y value. Then I'll put x here, put y here. So we say this.x is equal to x. So it's getting the x that's passed into it when we make a new version. Now, let's repeat that, -64, comma, and let's go 400. Because if you remember last time it was sitting there. Okay, so now it's further down. That's good. But let's go for head 2, and this time let's put this at 100. Why not? And now we can take these 2 objects and there we go. So now I have two objects using the same class. So this is a huge improvement because we've now encapsulated the code and now made it reusable for multiple versions. If we wanted to, we could then have other properties that we're passing in. So I could pass in a speed X or a speed Y. I could make these animate both X and Y and not just look for hitting on the X boundary, but what happens if I go off screen on the Y value as well? So how about this? We'd go Y plus equals 1, and then if this dot y is greater than canvas dot height, this dot y is going to be equal to, well, not minus, equal to negative 103. So let's see what happens now. We can see that it should wrap. And we can see it now came from the top. So we now have these. Not bad. What if we set our speed equal to some value? So we grab math.random, and that gives us a number between 0 and 1, and then we multiply it by the range of numbers we want. Let's say, so it could be between 0 and 5. Why not? Now if we look here, we'll see that, oh, we're getting some interesting stuff going on there. Oh, I don't want to be changing it during the update. I probably want to set that because otherwise we get this kind of wiggly, it's going faster and slower, but hey, it's not smooth motion, but it's got variety. That's kind of cool. But we could go this dot speed x is equal to math.random times 5. This dot speed y is equal to math.random times 5. So that will be speed x. And speed y. So now, oh, and we get an error message here because, let's see, speed x is not defined because it's looking for speed x, but there's no global speed x, which is what this would refer to. We need to say this dot speed x, this dot speed y. Now, no error message, and we can see they're moving very differently, but now they're moving where they have a consistent velocity. Their speed isn't going faster or slower as they animate across the screen.